Hi guys, so today's topic is solving rational equations, okay, which is not going to be as bad as it sounds. All right, there are three different methods that you can use to solve a rational equation. I'll tell you right off the bat that this guy right here is my personal preference, but it's always a good idea to just have a couple of extra tools in your tool bag. So I'm going to show you how to do all three of them. I'm never going to ask you to use one particular method. I don't care which one you do. It's a preference thing. So it's just kind of just letting you know. All right, so there's three different methods. There is one thing that you need to make sure you watch out for, and that is our good friend, the extraneous solution. Okay, so remember, extraneous solutions are extra solutions that get shoved into the equation along the way while you're solving. And the only way that you can tell that they happen is by checking your answers at the end. Okay, so you want to check your answers at the end. And in this case, the big thing that you're looking for is you got to remember that you can't divide by zero. Okay, so any factors that are going to make the denominator of your fraction be a zero, that's a problem. Okay, because remember, fractions are just dividing. So with this guy right here, if I solve this and I found x was -4, that would be extraneous because when I plug in the -4, this becomes a zero and I have 3 divided by 0. Okay, this problem right here, if x was 0, I'd have a problem because 4 times 0 is 0, 7 divided by 0, can't do that. Okay, so that's the big thing that you want to look out for when you're doing these. All right, so without further ado, let's talk about method one. Okay, so method one, this is my personal favorite. All right, and the basic idea here is that you want to get rid of your fractions. Okay, and if you remember at some point in your life, you probably had to solve an equation that looked something like this. And maybe you had a teacher who taught you, oh, well, if you just find the least common denominator, 6 in this case, and you multiply the entire equation by that number, it clears out your fractions, right? So this guy, make that 6/1. I've got a common factor of 3 that'll cancel. So that's going to work out to just 2 times 2 is 4x. 6 times 1/6, that's just 1. And then 6 times 5 is 30. And now you've got an equivalent equation you can solve with no fractions in it. Okay, so that's the same basic idea for how you solve a rational equation. It's just, a little bit fancier. So what you want to figure out first of all is figure out what is your LCD for this problem. So when I look at this guy, right, hopefully you remember LCDs from adding and subtracting, and you can see, okay, my LCD is 4x. Okay, so I can multiply all of these denominators to be a 4x. So I'm going to take this whole equation, I'm going to multiply it by 4x over 1, if you will. All right, when I multiply this first fraction, those x's are going to cancel each other out, right? And then 4 times 3 is just going to be 12. Yep. And then the next one, common factor of 2 will cancel. So that's going to end up 2x times 5, so 10x. And then in the last one, the whole 4x is going to cancel. So that's just going to leave me with 7. And now we get a little baby equation that I know you know how to solve. Subtract the 12 from both sides, divide both sides by 10, -1/2. And then just a quick check to see if it's extraneous. If I plug this in for x, is that going to make any of my denominators 0? Nope. So we're all set. There's my solution. Okay, so that is method one. That is my personal favorite. All right, method two. Okay, the idea with method two is that you basically just want to get common denominators across all of your fractions. All right, and as a simple example of this, if you had an equation like x/3 plus 1/3 equals 5/3, right? Because the denominators are all the same, it makes this equation pretty trivial, right? You're basically just solving this equation up here, and it's pretty obviously 4, okay? So that's the same concept that we're going to do here. I'm going to start by getting common denominators across all of these, right? And that's going to end up being 4 times x plus 4. So I'm going to have to multiply this guy by the 4 top and bottom. This 2 is going to get multiplied by the whole thing, top and bottom. And then this guy is just going to get multiplied by the x plus 4, top and bottom, right? So here I'm going to end up with 12 over my common denominator. This guy I'm going to end up with 2 times 4 is 8, so 8 times x plus 4 over my common denominator. And then this guy will end up x plus 4 over my common denominator. All right, you may be looking at that and you might be kind of tempted to cancel these guys out. They do look very tempting to cancel. But remember, the goal here is to get common denominators. And if you do that, we're going to be right back where we started from. Okay? All right, so from here, the next thing that you want to do is once you get common denominators, you're just solving the equation that is the numerator. So in this case, my equation is going to be 12 plus, and I'll go ahead and just distribute that as I go, 8x plus 32 equals x plus 4. And then you know how to solve this from here, right? I'm going to subtract the 8x from both sides. This is going to be 42 or 44x. I'm going to bring the 4 over. It'll just be 40. And then divide both sides. I'm going to get negative 40 over 7. Okay, quick check. Is that going to make anything 0 in the denominator? Nope. So I'm good. Okay. All right, so that's method 2. It's actually very, very similar to method 1. You're doing a very similar thing. I personally don't like it just because I feel like there's a lot more writing and a lot more places for you to kind of mess it up. I like this one a little bit better because it just kind of like gets rid of stuff. Okay, so that's kind of my personal preference. But again, you might like the second one better. That's cool. All right, and then this last one, method 3, cross multiplying. Okay, so I bring this one up because for some reason, cross multiplication seems to be the one thing that people remember really well from middle school. So it's something that is kind of a good fallback if you ever need to use it and you can't remember how to do the other methods. Okay, now there are some drawbacks to it though. Drawback number 1 is if I wanted to solve this with cross multiplication only works when you have a fraction equaling another fraction. So I'd have to start by combining these two, getting common denominators and adding them, and then I could cross multiply. So it's sort of an extra step. And then problem number 2 that comes up with cross multiplication sometimes, when we did this one, we ended up with just a linear equation to solve that was pretty easy. If you do it with cross multiplication, a lot of times you might end up with like a quadratic or a cubic equation, and that's just a lot more work to end up solving. Okay, so cross multiplication, it's a good fallback method, but it's not my go-to. Okay, but the general idea is you multiply your diagonals. So x times 3 is 3x. 2 times 2x minus 1, so distribute there. And then you know how to solve that. I'm going to bring that 3x over there and the 2 over there. There's my solution. Okay, and if I check that, plug that back in, nothing extraneous, we're good. Okay, so that is cross multiplication. Those are your 3 methods. And again, I don't care which one you do, you just need to be able to solve these equations. So from here on, I am going to stick with method 1 because that is my preference. And I think it'll probably be your preference too, based on what I know about you. All right, so looking at this guy, I want to figure out what my LCD is. So hopefully you can look at this and pretty easily recognize that it's going to be 3 times x minus 2. So I'm going to multiply this whole equation by 3 times x minus 2. This fraction, the x minus 2's will cancel. So 3 times 2 is 6. This one, the 3's will cancel. So I'm going to have a minus 2x times x minus 2. And then in this one, the 3's will cancel, and I'm going to have x minus 2 times x minus 3. Okay, clean it up a little bit, do some distributing. That's going to end up minus 2x squared and then plus 4x. And then over here, that's going to work out to x squared minus 5x plus 6. Okay, if you don't believe me, go ahead and do a double distributive property on that one on your own. All right, and then this is going to be something quadratic. I'm probably going to have to factor to solve this. So I want to get all my x squareds in the same spot, and I want them to be positive. So I'm going to move everything this direction. Okay, so I'll add that 2x squared over here. That'll give me 3x squared. Bring that minus 4x over. And then actually the 6's are going to cancel each other out, right? Subtract that 6 from both sides, they're just gone. So I can solve this with just a GCF. So that's 3x times x minus 3. 2 possible solutions are 0 and 3. And if we go back and check those, if I plug in zeros, that can make any denominator 0. Nope. 3. Nope. So 2 solutions. Voila. All right. Moving on, this guy down here. First thing I want to recognize is that I can factor that denominator. Always factor them when possible, because that's going to make your life much easier. Okay, I don't want my LCD to be x squared minus 9 times x minus 3, right? I just want my LCD to be x plus 3 times x minus 3. So always factor those when you're looking for an LCD. Okay, I'm going to multiply this whole thing by that x plus 3, x minus 3. This guy, whole denominator cancels out, just left with the 30, beautiful. This guy, the x minus 3 will cancel, so I'm going to be left with 5 times x plus 3. And this guy, sadly, nothing cancels, so I'm going to have -1, and then I'm going to have to multiply these guys back out, but I already know that they multiply out to x squared minus 9. That's where I got it from, so I'm just going to go ahead and write x squared minus 9, save myself a step. Okay, all right, distributing a little bit, try to clean this thing up. That's going to be a 5x plus 15 minus x squared plus 9. I want this guy to be positive, so I'm going to move everything over to the left side of the equation. That'll give me a positive x squared, then a minus 5x. And let's see, that's going to add to 24. And when I subtract it from both sides, that'll leave me with a positive 6 over here. So 2 factors of 6 that add up to -5, -2, -3. My 2 potential solutions are 2 or 3. Quick check, 2 is going to be fine, but 3 is actually going to make both of those denominators 0, right? So 3 is an extraneous solution, and my only actual solution is x equals 2. All right. One more, just to make sure you're good with this. So this guy I can factor to x minus 1, x plus 1. Always factor them if you can, which means my LCD is just going to be x minus 1 times x plus 1. So I'm going to multiply the whole thing by x minus 1 times x plus 1. This guy, the x plus 1s will cancel. So that leaves me with 4x plus 1 times x minus 1. I'll have to multiply that out in a minute. This guy, nothing cancels, blah. But again, I know that this multiplies to x squared minus 1, so I'm just going to go ahead and write x squared minus 1. And then equals the 12, everything's going to cancel. It'll just leave me with the 12. Excellent. Clean this up a bit. Double distributive property. I'm going to land with 4x squared. I'll have a minus 4x and a plus x, so that's minus 3x, and then minus 1. And then I'll have a minus 3x squared plus 3 equals 12. These guys will combine to a positive x squared. And then I'll have a minus 3x. Let's see, that's 2. Subtract that 12 from both sides. I'm going to end up with minus 10. So that's x minus 5 times x plus 2. And my 2 potential solutions are 5 or -2. Either one of them extraneous. Nope, not going to make any denominators 0, so I'm good to go. 2 solutions. Okay, so again, 3 different methods. I don't care which method you use. Pick whichever one you like best, all right? And you should be all set.